Good morning, good afternoon, and perhaps good evening. We welcome you today to our session where we'll be covering AutoSys workload automation in cloud environments. I am your host and moderator, Scott Wilson. A couple of house cleaning things. I will be moderating the Q&A session after the presentation is done. You may please feel free to enter your questions to the right-hand side. There's a little box that allowed for questions, the presenter and audience chat, so you can go ahead and click in. We also would like to encourage you to provide feedback when the session is done. We definitely love your feedback. And without further ado, let me introduce our two speakers today. First, I have listed here is we got Dan Shannon, and he is our Senior Product Line Manager. Dan spent most of his career working with automation and is currently, as I already mentioned, the Senior Product Line Manager responsible for distributed automation products, including AutoSys and D-Series. And he's going to be accompanied by Richard Cow, who is a solution architect. He has had 28 years of experience, has been at CA, Broadcom in various roles in R&D, and he is currently responsible for the architecture of AutoSys, D-Series, and their agents. And with that, I will turn it over to these gentlemen. Take it away.
Thank you very much, Scott. So get started here. So our agenda today is we're going to a little bit overview about cloud environments as a whole, and then look at automation specifically with AutoSys and how things are done there, and then take a look at some recent enhancements that were done for the AutoSys 12.0 release, and then kind of wrap things up with a demo, and then just some additional information, and then finally with some questions and answers. So first, looking at kind of an overview, just talking about cloud support. And this is cloud support means a lot of things to different people. And so what I did is I've just captured a definition from Wikipedia on cloud computing. And without reading it to you, essentially my interpretation of all this is it provides the ability to run applications in a generalized data center environment that may potentially be shared by many users. So cloud, in other words, it could be, it uses a term to represent data centers, shared services that may be used by multiple organizations. It may be, in that case, it's public. It could also mean a private environment that's dedicated to specific customers. But it's also related to applications. So we hear the term used in a lot of different ways, and we're going to try to cover as much of that today as possible, certainly at a high level. But the bottom line, what you'll learn today, is that AutoSys, which has been around for 30 years, is very much cloud capable of running these applications existing in these environments today. So first thing we'll talk about is deployment. So where is AutoSys running? AutoSys can run on-prem. It can run in a cloud, such as environments such as AWS, Azure, or Google Cloud Platform. Or it can run in a hybrid environment. So the hybrid meaning the AutoSys can either be on-prem and with parts of it on-prem and parts of it in the cloud. And just want to point out also that in the environments AWS and Azure, AutoSys also has the capability with the database of using those consumption-based licensing for the database. So Amazon has its relational database service. Azure has Azure SQL Server. With GCP, we're still have to run in a bring your own license type of environment. So where you would install your database, and then AutoSys could leverage it there. So first, looking at applications. So as I mentioned, applications we have legacy applications, of course, command line type applications that AutoSys has been scheduling for years. Certainly, as of the 11.3 release, AutoSys was able to schedule a lot of different types of applications beyond just command line, whether it's SQL queries or SAP, PeopleSoft, ERP systems, just various integrations there that were all prior to web services. There was some support for web services, but certainly the number of applications written using them was very limited. And that, of course, has increased over time. So when we look at cloud applications or cloud environment, there's three architectures that are common. Infrastructure as a service, the IaaS, which is essentially like putting one of your VMware, a VMware guest, putting it in the cloud and running it that way. So it's typically referred to as a lift and shift, where these virtual machines are run in the cloud. Your applications don't change. It's just the location. So you're moving a system from the data center, the on-prem data center, to the cloud. And then you have your PaaS environments, which include things like Pivotal Cloud Foundry, OpenShift, Kubernetes, where applications are actually written to take advantage of the platform services that these PaaS solutions provide. And then SaaS, which is the software as a service, which is typically it's an application that's provided. Some vendor, someone has written an application, could be an internal application, but it's written such that the primary way of interacting with this thing is through web services. And there's no command line utilities, that type of thing. It's not typical. So AutoSys has the ability. If we look at the left side of the diagram, we see the AutoSys components there in purple, and that's indicating the on-prem environment. We see a couple of firewalls that are being traversed. And then on the right side, we see various applications. So it could be containerized applications, as I mentioned, Docker, Mesos, Kubernetes, those types of things. Could also be HTTP jobs, which includes HTTPS, web services, or your lift and shift machines. All those could be in the cloud, and AutoSys can automate all that from your on-prem data center. Next is the infrastructure as a service. AutoSys is, in this case, is running in a cloud environment that would be essentially a virtual machine running in these clouds and talking across the firewalls back into the on-prem solution where it continues to run the application. So in this particular example, would be someone that has migrated AutoSys to the cloud, AutoSys service itself to the cloud, and is running their applications on-prem, and essentially something we see a lot of times as customers are making the migration from an on-prem, completely on-prem deployment to a situation where things are in the cloud. So whether customers move their applications to the cloud or the AutoSys service to the cloud, at some point the order is kind of irrelevant, but this is certainly one that we see. Next is a hybrid environment, which is the most common that we see. And hybrid, it could be either way. It could be AutoSys on-prem or AutoSys in the cloud. But we see applications that continue to reside on-prem, as well as applications that are evolving, and new applications that are being developed in the cloud, and having AutoSys provide the ability to schedule both of those. And so AutoSys supports all these. It's very easy to do. Certainly provides a lot of flexibility as you move from 100% on-prem environment to some sort of cloud environment. AutoSys is there to be able to take advantage of that. So next we'll take a look at how these applications are automated. So AutoSys, of course, has operates in job types. That's the unit of work, or actually the job is the unit of work. The job type is the classification of the job, closely associated with the application technology itself. So with the PaaS and SaaS type applications, of course, we're working with web services to be able to interact with these applications. And so the primary job types that are available are the HTTP job type, which can be used for the RESTful web services. Then it's a legacy and older standard of SOAP, which was the RPC web services. That's still supported, but that's a standard that is clearly beyond its time, and has been replaced with the SOAP document literal job type. And so the WSDoc. So between the two, the HTTP and the SOAP web services, the WSDoc, those are the two most common for calling web services. And those two don't require any coding on your part, the application developer, to be able to automate their applications with these. And then there's other job types that are frequently used is the Pojo, or plain old Java object job type, and it could be any scripting languages could be used as well. Certainly Java is very common in the enterprise world. Java is a common language, so a lot of people have, a lot of companies have skilled people with this skill set, able to leverage this language. And then the command job type, of course, is one of the original 3 job types that AutoSys supported, and it's really about executing command line utilities, whether it's a program itself or whether it's a script, but being able to leverage those, and that job type, along with utilities like curl. There may be thin client utilities such that some of the containers provide, container managers like Docker or kube control for Kubernetes, and so forth. So just another example of a way to automate these applications. And so start look at some of the job types. So this is an example of the HTTP job type used to call a RESTful web service. The actions supported by the HTTP job type are get, put, post, and delete. So those are the common HTTP actions that that are used by various web service applications. So this is just an example of that. We'll look at some of these in more detail as we go along. And then here's an example of a SOAP document literal job type. You can see the URL. One of the things that was enhanced for the 12.0 release is to support the standard XML. You can see a little example of that at the bottom of the screen here. But it provides the ability for you to specify the URI or URL and the XML associated with, which is essentially the SOAP envelope to create the request. There's a Browse WSDL button there, which allows you to easily define your envelopes and just be able to fill in the data. So it's pretty easy to use. And next is the plain old Java object. So the Pojo job type has been around since the 11.3 version of AutoSys. And it, as many of you know that are using AutoSys, the agent is written in Java. And this is really just a way of extending the Java capabilities that the agent provides, extending it to applications. So with this, there's some requirements, pretty minimal, is that the Java program has to contain a default constructor, so no arguments, has to use instance methods, methods that are associated with the class as opposed to a static method. So it has to be a member of that class. And then it has to return basic types. So it doesn't support a complex object or anything like that, returning it, but it does return the basic types. And of course, this information, what's returned, is generally used for either determining success of the operation, the execution of the job type, or some sort of data that could be shared by others. And so this is just an example using Pivotal Cloud Foundry, and we'll see this done in a couple of different ways, just to show that there are multiple ways of automating these applications. This is using the Pojo job type, and there's 3 jobs here that are run. One is associated, the first one is about getting a token from PCF, and then the second one is extracting the token, and then the third one is about actually calling the application. So the data that we'll see this is passed between the various job types, the job executions, and it's collected and then eventually passed on to that last application that is calling the PCF application itself. So here we have a look at the WCC interface, and the things to point out here is that this is a SOAP call, or I mean, sorry, this is it's the Pojo job type. It's going to be calling the class, this class HTTP client, and it's going to be calling a method name called postSecure. We pass a number of arguments to it, and when it executes, it's going to return some data. And this is the second job that is actually, the first job returned the token, as I mentioned, in the JSON format. And then this particular job, you can see at the bottom there, J2EE parameters. This is what we call a payload consuming job. So it's going to consume the payload from the first job, the Pojo get token, And using the JSON parser, it is going to extract the access token, which can then be used to call the application itself. And so this is the last job in the chain. You can see at the bottom, it's also a payload consuming job. It's consuming the payload from the Pojo extract token job type and calling the URI listed there in the fourth argument. And so this is an example. The Pojo example is something that it's certainly available to all releases of AutoSys 11.3 and up. And it's something that could be used even with the latest releases of AutoSys. There certainly in later releases of AutoSys, there's easier ways, most likely, of doing things. And this is an example using a command job type, the tried and true command job type that was really the kind of the foundation for AutoSys. In this particular example, we're calling the curl binary, and we're actually, this is just an example of calling one of the AutoSys RESTful web services, just kind of demonstrating a way that web services can be called using a command job. Certainly, this could have been a script, with extensive error handling and different types of logic associated with it. It's just another way of doing things. And then using that same example with Pivotal Cloud Foundry, done using the command job type. So first job type is actually running a script that is going to start the Pivotal Cloud Foundry application. And then the second job is actually calling the endpoint. It's this happens to be an HTTP job type. It's calling the endpoint there and looking for a response from the application. In this case, it's just a simple hello world that it's looking for. And assuming that HTTP call returns that, this job would end in success. So just a pretty simple example. And then now just taking a look briefly at some of the enhancements made to AutoSys 12.0. So 12.0 introduced a feature that's called Web Service Orchestration, and it provides much more robust support for REST and SOAP web services. The HTTP job type was greatly enhanced to support REST, so non-form-based HTTP calls, and then the SOAP web service was also enhanced. We saw a little bit of that at the first screens. Those are the 12.0 dialogues. The SOAP web service, as I mentioned, one of the enhancements was supporting a standard XML as opposed to a flattened version of XML. So with the web service orchestration, certainly beyond the protocol enhancements, one of the big benefits is data sharing. And that's really, web service orchestration is comprised of enhancements to the protocols support itself, as well as the orchestration of the jobs, being able to share that data easily. So whether it's data that's being shared from a security header, from one job type, like a bearer token being passed on to subsequent web services, or whether it's data that's being shared, from a response, a piece of it, or pieces of it that are being passed on to other web services. The 12.0 implementation has greatly simplified how things are done. It's also reduced or eliminated some of the restrictions that were there in the 11.x versions. such as dependent web service jobs used to have to run on the typically on the same agent, or the responses that were persisted had to be persisted across a shared file storage. So all this is completely removed with the 12.0. That support is still there if you're using that functionality today, but it's not required. With the orchestration being handled by the scheduler itself, that allows you to take advantages of agent farms and virtual machines, load balancing, those types of things, to be able to share these. As I mentioned, we introduced the standard XML, making it easier for application developers to adopt the automation, so that someone that's using a Postman or SOAP UI to test out their applications, they can literally just copy that envelope, the XML envelope from those tools into the job type and be able to execute that. HTTP header support was also added. So in the 11.3x version, it was kind of supported. It was more a kind of a side effect than it was some actually deliberate implementation. But certainly we provide a way to take advantage of the HTTP headers explicitly, so there's no confusion, no ambiguity at all the way the applications or what data is being shared. So at this point, I'm going to turn it over to Rich Cow, our distinguished engineer, and actually give you a little demo on this technology. So, Rich.
The demonstration. So I'm going to show you two techniques for basically, how to interact with, third-party web services or even applications as well. And so right now, the first way to extend it is using the Pojo job type, which Dan touched on a little bit about in his part of the presentation. And the second one is the new feature, which is Web Services Orchestration, which highlights most of the enhancements that were made to both the SOAP and the HTTP job type. The demo that I'm going to give is concerning mostly around the HTTP job type with REST web services. So, there are various aspects to the web services orchestration that will be touched upon, which is, both the making REST calls and all the different attributes that you can change when you make a REST call, as well as the post-processing of the response that's returned from the RESTful web service. So in this particular scenario, this particular use case I'm going to cover is using a third-party application that's a real-world application that we actually did an integration with and worked with a customer to do. And this involved, it's a cloud-based SaaS application, which is a publicly available application. And we are using their APIs to basically interact with their application to run this. And the application we're doing here is DBT, which is an ETL type of tool, data warehousing type of tool. And the architecture sits like this, where we have the scheduler, which is what you all know today, the agent, which is still the same agent as before, and we're going to be using the application services plugin, which contains the HTTP, and then we're going to be communicating over the internet to the service provider, which is the DBT web service provider. So the flows go here that you'll see there's two RESTful web services being called. The first one is to trigger the job to run inside of the DBT application. And the second one is to monitor that job, because the DBT trigger only returns to you a run ID, and then you have to monitor the run ID until completion. So these two web services are going to be called. And so just another little brief touch up on what the requirements are for Pojo. This is a little bit more in detail than what Dan presented earlier. So it is a standard Java Pojo object. There's nothing really special about it. Their default constructor with no arguments, single method invocation, basic argument types, which is what Dan covered. The other things about the deployment of how you get it out into the agent is that you can use any third-party jar files out there to do your implementation in Java. The only requirement that we have is that you have to restrict yourself to the jars also that are provided by the agent. You cannot change those jar files, but you can use them. So for example, the agent does ship a few jar files that are open source, like the Apache HTTP client. It also ships like the Bouncy Castle jar file for security encryption. So there are certain jar files out there. So you can reuse those jar files in your applications, but you cannot change the versions. You have to leave them at the same version. So I will quickly jump out to just show you the Pojo. So just a brief touch up on the API. So like this is the DBT application, and these are the REST API calls that we're going to be making. And this is the first one, which is the running of the triggering of the job, and the second one is the run to get the status information of the job. And the actual job definition looks something like. So what I have done is I have already pre-deployed some applications in here. And so this job here is using a Pojo object. So if we look at the details here on this, you'll see that here's the method name that I'm calling, which is the Pojo class the package. This is the method that I'm calling, and these are all of the arguments that it takes. So this one here is the token. And then there's some extra arguments for proxying and stuff like that. This is the endpoint, and this is like the org identifier, the application identifier. This is some textual notes. So this all maps to the API that we were calling on here. So here you'll see that it requires an account ID, a job ID, as well as some data to be passed in the payload here. So this whole section here is just how it's done. And when it's deployed to the application, you deploy it into this directory here, which is the agent's directory. The agent installed here. There's a jars directory in ext. And basically everything you see in red here is something that I added to the agent because I wrote a Pojo to do some extra functionality. So like the DBT jar file here is the jar file I wrote to actually communicate with DBT and submit these jobs. And these other jars here, like this one here, is a helper utility for this one. This is something Dan showed you some stuff with Cloud Foundry. So this is a Cloud Foundry jar. This was an OpenShift one that I wrote, and SAP. So these are other Pojos that I implemented, but this demo is specifically centered around the DBT one. And the DBT one uses some other third-party jars that were deployed, which is this Java one, these two Java ones. This is for JSON parsing. And it also will use this utility jar file as well to make the HTTP call. And this HTTP Pojo actually utilizes the Apache HTTP client to actually submit the request. So you'll see these Apache, these two here. These are shipped with the agent, and this is the Apache HTTP client jar files. So basically that's all you have to do is you copy it here, you restart the agent, and then it becomes available, and then you can make the call to call it. So that's a very quick overview of that. So now to switch back to the slides. So the next So the next use case will be to do the exact same thing, but this time I'm going to do the same thing that the Pojo does as a single Pojo, but this time I'm going to make individual HTTP calls as individual job types. And so this is where, I had shown earlier the REST API. So these are the pieces that you need in order to build the job. So the operation type is post. The endpoint is it's going to be like HTTPS with the URL endpoint, and then there's an account ID and a job ID that you have to supply. And the headers requires that it's a bearer token, and the bearer token is generated from the DBT application. And we have to set two header types. One is for the accept, which is how the DBT application returns the data, so it's going to return it in JSON. And the content type, which is the data that we're actually sending to the application, which is also in JSON. So the content type is for what we're sending, accept is what they're sending back. And the payload that we're actually sending is this small JSON, which is cause, and it says started by AutoSys. So then the next job type that gets executed, and this is the response that comes back. And the value that you see in green is the value that we need to extract and save off as a job variable. And this is a new functionality that's in R12 that allows you to persist data from the response into the scheduler side, and it can be used in any job type in another job after that. So the next job that happens after that one is the trigger job. I mean the status job. Basically, we're going to get the status of a particular of the job that we just started, and that's done through a get operation. The endpoint here, and then you'll see here that the run ID is in green. That's the job variable that we need to save, that we saved off in the previous job, and we're going to have to insert it into the next job at runtime. And also it takes a token and it returns, we're telling it to return the response in JSON. And the response that comes back will look something like this. And in this particular job, what we're going to do is we're going to use some of the new features, which is the success criteria. And we're going to use the success criteria to alter the status of the job based on data that's being returned. And in this particular case, we're going to be looking for the status to be returned as 10. So you see that green 10 that's in the presentation, and that variable status will be set to 10. And if it's set to 10, then it will be marked as success. And we're going to retry because this is an asynchronous call, so we have to retry to actually re-request it, check the value. If it's not correct, then wait a little bit and then retry again. So that's basically what we're going to do for this particular demonstration. So I'm going to share the demo. Okay, so here we are again with the same WCC instance that we were looking at before. And this time I'm going to concentrate on these jobs over here. So this one and this one. So this one was the first job that was in the presentation for the starting of the job, the triggering of the job. And if you look at this particular layout here, this is the new R12 layout. And you'll see here is the endpoint URL that I had specified before. And I filled in my account ID and my job ID here. So this is supplied by the application. And here I'm setting the content type to application JSON. And here you'll see I am setting the payload, which is the payload that I said before. And in the headers, I'm going to set the headers for the bearer token. And the only other thing I need to do here is the response variables. And here is where I am extracting the data from there. So I have captured the actual response. So here's a response that we would get. And we're going to be trying to extract this value right here from the response. So we have a helper utility in the WCC that will allow us to do this. So I'm going to copy this JSON, the sample JSON here. And I'm going to hit the Evaluate All button and paste the JSON data into this. and hit the evaluate button. So what this does now is it allows me to use this button over here to view the results, which will actually evaluate this JSON path expression against the data that I just entered and show the result. And here you see the value, 6468113. Right? And this matches the value that we were looking for, which was this guy here, 6468113. Right? So that was the first job. So this job, then we saved off that variable. Then the next job, we require that we need to use that value. So in here, you'll see the basically same thing again. This time it's a get operation, and here's the endpoint URL. But I need to insert a variable here that has the actual value of the run ID that I got from the previous one on the start. So how you can figure out this, it's a little bit cryptic, but we do create this generate expression dialog. And this will allow us to create that dialog so you don't have to remember how to do it. So what I could do is I could just pick the job name where I want to get the variable from. And in this particular case, it was the trigger job. And then I'm going to say response variable. And I had saved it earlier into a response variable, and this is the run ID. Right? So here is the variable, the variable that's generated that I have to use in the expression. So I could say copy, and then I could just paste it right into here. So this is how it gets and what happens is that when the job executes, the scheduler will substitute this value in at runtime. So once again, I'm setting a header, the authorization bearer token. I'm also setting the response type. And in here, I'm going to use the success criteria. So here I'm going to say, look at the success criteria works off of the response data from the job. And so I'm saying here that this is going to be, use this JSON path against the response and then evaluate it against this. So if that value matches, then the job will be marked as success. If the value does not match, then the job will be marked as failure. So this is a repetitive job, a cyclic job, meaning that it has to be run multiple times in order to get the proper success code in order to mark the job as success. So in order to do that, because the very first time I run it, it will probably be a status of 1, which means it's executing. And I need to keep calling until it changes to 10 so that the job will be marked as complete. Since I don't want the job flow to fail just because it's still executing, what we can do now is that in the connection parameters dialog, we have this retry failure count. So basically, because this will cause the job to fail, but because I have a retry set, then this will retry 60 times with a 1-minute delay between each retry. So then the job will not be marked as complete or failed until either the retries have been exhausted. So if the status says running for longer than 60 times 60 seconds, which is approximately 3,660 seconds, or 60 minutes or an hour, then the job will be marked as failed. But if the job changes, the status changes to a 10, then the job will be marked as complete. The retries will stop retrying, and the job will be marked as success. Right. So what I could do is I can actually try to run this job. And let me bring up this here too. So what we're going to do is I'm going to do some auto repping to look at the job. All right, so when actually I don't have to do auto, I can just use WCC. So when I run this job, then the job will be run. So it's starting to run, and then it executes. So now you see this other job is running. So when I look at this particular job, I can look at, this is also a new feature in WCC, where you can now look at more details of the actual execution. So in the spool file, you'll see some details like this. So here's the request header that's being sent, the request details where I'm posting, And here is the response that came back, and here's the response data. So it was successful, so it was marked as complete. And if we look at the second job, which is this one here, which is executing, oh, it's still executing. But we can look at the status while it's executing. So here you see that this is the request that I made, and you see how it properly filled in the job variable with the job run. And here you'll see that the first response came back, but if we look at the status, here you see the status right here, and the status is set to 1, which is executing, right? So here you see that the request did not match the success criteria value, which was 10, what we were looking for, 10. So now it's going to do the retry. So here's the retry going through, makes the same request, and the value here is still, the status is now 2. And, oh, this time it's going to take longer to run. So this is actually taking longer to run this time around. Oh, now it completed. All right, so I can take a look at it. Okay, so now if we look at the spool file again, so here we go. This is the first run again, and here's the first retry. We saw that this one had returned a status of 2, which is right here, status of 2. And then, since it didn't meet the 60 retries, so it's going to try again. And this time, the status returned is 10. So here you see a status of 10. And the run was marked as success. So that's why you see success here. And in AutoSys here, you'll see a job is marked as success. So that's basically, this is exactly what this Pojo object was doing, except this time I ran it through using our WSO capabilities. So that's that would be the end of this particular presentation. So I think I could just switch back to Dan, right?
Yes. Okay, so just other things to note here. Just keeping up to date with what's going on with AutoSys is the community.broadcom.com site. A lot of it's like a bulletin board type of thing. Not only do Broadcom CA people respond, but customers respond to a lot of things. Certainly a place to post enhancements and just ask questions and such. And then participating in the Validate site, the sprint reviews as we continue to develop the product and we demonstrate the functionality to customers. We strongly encourage customers to register, be able to participate in this. There's no obligation. It does give you access to early releases and as well as demonstrations of functionality. And the most important thing is the ability to provide us feedback so that if a feature that we're developing does not appear to be meeting your needs, that we get that feedback, are able to make those enhancements, or certainly get positive feedback that it is meeting the needs. But, both of those are very important. And then lastly, the next AutoSys Roadmap webinar is listed here, July 28th, 11 a.m. Eastern Daylight Time. So you see what's going into the next release and future. So at this point, open it up to questions.
Perfect. Thank you both, Dan and Rich. We really appreciate that. We do have some questions. So the first one I have is AutoSys 12.0 generally available?
And the answer is yes. 12.0 went GA on June 26th.
Okay, perfect. Next one, can OpenShift/Kubernetes apps be automated using AutoSys?
Absolutely. So although we didn't demonstrate it here, that's certainly something that can be done today. Can be done using the Pojo implementation with the GA releases today. Can also be done by calling the web services themselves using HTTP job type to be able to do this. That is something that we'll also be planning to make even easier in the upcoming 12.1 release.
Okay, perfect. And then there's one more question, it looks like. Are you using the tool automation AI, or JAWS as it used to be called, for AutoSys workload management? Or perhaps, yeah.
So it does, AI, or formerly known as JAWS, that product does work with AutoSys, works with all releases of AutoSys. It's not something that we demonstrated here today, but it works with AutoSys as well as a number of other schedulers. It's also capable of running in cloud environments and supporting AutoSys that's running in a cloud or hybrid environment.
Perfect. Well, thank you, gentlemen. We appreciate everyone's comments, feedback, and we appreciate your time. This webinar, of course, will be available on demand. You can find us on brighttalk.com, and of course, please visit us at broadcom.com to learn more. And with that, we will wish you a great evening, afternoon, or morning. Thank you.
Thank you very much.